There's 9 core steps to delivering a construction project. Construction projects are not complex. Calculus is complex. Quantum physics is complex. Construction management can be complex or it can be simple. It's similar to IKEA furniture. Assembling IKEA furniture can be complex or it can be simple. If you rush to put the furniture together, you ignore the manual, you don't follow the steps, it's going to get complex fast. However, if you are patient, you follow every step meticulously, then assembling the furniture will be relatively simple. When I understood this, it changed how I saw construction management. It's simply a process we need to follow. How well we follow the process determines whether it's simple or complex. Whether you're working on a $2 million commercial construction project or a $250 million solar farm, the core steps remain the same. Sure, the level of detail and the effort, the fact that you're outsourcing them to different team members will change, but the core steps are fundamentally the same. In this video, I'm going to walk through these 9 core steps to delivering any construction project. But first, I quickly want to talk about 3 inherent characteristics of construction projects that we need to consider when we're talking about following these steps. I like to think of these as the elephants in the room that a lot of project management courses and textbooks don't address. The first of these, the true challenges of construction management, is that you're always going to have too little time and too few resources to get the work done. Your team will be too small and there'll be too many tasks you need to perform. Most project management theory just has too many tasks in it. You look at something like the PMBOK and there's 49 separate processes to manage a project. Projects are never resourced properly to follow these steps. This creates a situation with our limited resources we need to prioritize. What are the important tasks we focus on with our limited resources? Challenge number 2 is at the start of the project, we're not going to have all the information available. There's always going to be known unknowns. So there's going to be certain risks around, such as design development, inclement weather, productivity rates. So these are our known unknowns. And then we've also got our unknown unknowns. So these are things like COVID or other black swan events that could completely derail the project. So there's always going to be these sources of uncertainty that prevents us from perfectly planning the project. We can't perfectly plan and prepare without perfect information, and this leads to the concept of progressive elaboration, where information reveals itself throughout the course of the project. The conclusion of this is that perfectly planning is impossible, and we need to be adaptable and ready to change. And then challenge number 3 is the further the project progresses, the less control we have over the outcomes. If you've ever seen this graph, it's a representation of our influence over the project outcomes over time. So on the x-axis, we've got the project lifecycle, and on the y-axis, we've got the level of influence. Say, for example, in the conceptual planning stage of a project, we can make the decision whether or not to include an elevator in our lift. As we get to 50% of the way through the project, we've already cast the floor slabs, we've already built the structure of the building. We can't then suddenly decide to include an elevator. Well, we can. It's just going to be a very expensive change. Basically, what this means is as we progress through the project, we've got less and less control over the outcomes. Once we've locked in a subcontractor's rates, it's hard to then influence the cost of that subcontract package. Sure, we can avoid variations, but at the end of the day, we've locked in rates for that package of works, which is going to set a minimum price we can deliver the works for. Once the design is approved, it's difficult to further value engineer without causing disruptive changes. And once something is built wrong, we need to fix it. So as the project progresses, we lose control over our ability to impact the outcomes. So as we're going through the steps to deliver a project, you need to keep these 3 things at the front of your mind. Okay, so now we're going to go through the steps to successfully deliver a project, and we're going to start from the contract signing and notice to proceed. I'm intentionally not including the work winning and tendering phase during this because most construction companies will have separate teams that focus on work winning and tendering. The steps to successfully deliver a project are going to be broken down into 3 stages. We've got pre-construction, what we do before the work begins. We've got construction, what we do as the work's progressing. And then we've got closeout, so handing back the finished project at the end. Within any phase of the project, the steps within the phase can occur concurrently. And depending on the nature of the project, you may also have overlap between the stages. So here are the core steps we follow to deliver a construction project broken down into pre-construction, construction, and closeout. In the pre-construction phase, we need to understand the scope, we need to plan and prepare, and we also need to do any design and procurement. During the construction phase, we're going to implement the plan we've developed, and then we're going to track and monitor progress. And throughout this phase, we're going to control change. During the closeout phase, we're going to do our testing and commissioning. So we're going to verify and validate that what we've built is correct. And we're going to close out and hand over the project back to the client. During the pre-construction phase, we're preparing to do the work. This involves 4 core steps. We need to understand the work we're doing. So we need to have a clear picture and clear understanding of exactly what we're building. We want to plan and prepare, so develop a baseline, establish our systems and processes. We need to do any design work we need to do. This is the preparation of the drawings and specifications. And then we need to do our procurement. So we need to buy the external goods and services we need to deliver the project. In my experience, the hardest part of any project is to get a clear understanding of what we're actually building. And the trick is not to spend too much time doing it. Understand what you're trying to build through action. So start doing your initial research and developing your understanding. Speak to the tender team, get a download from them of the project scope, what exactly we're doing. Start looking at the key drawings and specifications like the overall site layout. I wouldn't recommend going into looking at detailed drawings until you get a clear picture. Projects that use building information modeling, using and looking through the model is a fantastic way to do this. Then also have a read of the scope of works or the contract. Then start doing something. Start going through your procurement. Start trying to actually complete a task, because you're going to have a much better understanding. You're going to naturally come across questions that need you to understand the scope. So my recommendation is don't spend too much time just sitting there, looking through drawings, reading documents. Start trying to complete a task and you'll naturally learn the scope through this. Next, you need to start planning and preparing to do the works. There's 2 components to this. There's developing your baseline, and then there's establishing your systems and processes. Our baseline consists of our scope baseline. So this is a work breakdown structure where we've taken the project scope and decomposed it into component pieces. We also need a budget. So we need to allocate the estimate, which was prepared at tender. Now remember, an estimate is the tender team calculating how much it's going to cost to complete the project. We want to turn this into a budget. So a budget is buckets of money we can allocate to different tasks. How an estimate is produced isn't always going to align with how we want to track and monitor expenditure. So we have to translate the 2. We also need to develop a schedule. So this is a detailed plan of how we're going to deliver the works. At tender, they might have created an initial schedule, but it's likely going to be high level and just broad estimates of the project duration that they've used to calculate overhead costs. We want a detailed schedule, which is an exact plan of how we're proposing to deliver the project. The gold standard, and I know this isn't always possible, but we ideally want a work breakdown structure, so a scope baseline. We want a budget and a schedule that all align. So the same work breakdown structure we've used to understand scope, we've also used to map to our cost codes, and we've also used to develop a schedule. Okay, so to clarify what I mean by having an integrated baseline, I've got 3 different colors representing scope in gray, scheduling in blue, and estimating in gold. So to start with, we develop our work breakdown structure. So we break the project scope down into component pieces. And then against each of these component pieces, we want to have a quantum of work. We want to assign productivities and we want to assign resources. So for example, we're building a car park. We've got civil works. We've got an activity, which is bulk earthworks in our work breakdown structure. There'll be a quantum of work. So say we've got 150 meters cubed of soil to move. We've got a productivity, 10 meters cubed to shift, and we've got resources we need to assign to that. Based on this, we can then create our schedule by putting all these activities in our work breakdown structure, and depending on the productivity we've assigned to them and the quantum of work, we can then sequence these tasks and develop a schedule model. So that's a Gantt chart. Then based on the quantum, the productivity, and the resources, we can work out how much it's going to cost to complete the task. And then once we've got our schedule model, we can then calculate our indirect costs. So indirect costs are things like project management, staff salaries, and those depend on the duration of the project. So we need to have our schedule model developed to do this. Then once we've got our direct costs and our indirect costs, we can calculate our total project cost. So you can see here, if we have an integrated baseline where we're using the same work breakdown structure to define and understand the scope, we're using this to create our schedule, we're using this to create our budget, then all of these activities are going to align and it's going to be much simpler to manage. And even during construction, it's going to be much simpler to monitor, control, and track what's happening when we're delivering the works. So I know I'm flying through these, but this is just meant to be a really brief, broad overview generally of how you deliver a construction project. I'm not going into too much detail. The next step is we then need to establish our systems and processes. So systems are things like what we're using to manage our document control, what we're using to manage payment and invoicing, timesheets, quality management. So these will likely be software tools. They could be as simple as Excel spreadsheets or certain other tools we use to manage our documentation. We've then got our processes. So process is something like an RFI process. So what do we do when we want to change the design? What does our monthly reporting look like? How are we going to manage payment claims? Who's going to prepare and submit payment claims? Who's going to prepare variations? What do variations look like? Do we have a template? So when we're planning and preparing, we need to establish both our systems. So what are the specific tools we're going to be using? And then what are the processes? So what are the steps we're going to follow to do all these different tasks? Now, depending on the specific project and the scope we're contracted to complete, we may have design work to do. So design is the development of the drawings and specifications that tell us what we need to build. It's going to depend on the specific contract model as to whether we have detailed design to do, so we're doing a full design and construct, or we just have some sort of vendor design like shop drawings that come through procurement. What we want to do when we're developing the design, regardless of whether it's vendor design or it's a full design and construct, is we want to manage the design to ensure that we're developing a technical solution that meets the client's requirements and the project requirements, but it's also constructible within our budgets. One of the key considerations we need to pay attention to throughout the design phase is scope creep. So defining something, saying we're going to build something that is not within the project requirements. So if the project requirements say we only have to build a fence that's 1.2 meters high, then we don't want a design that says we're going to build a security fence that's 2.5 meters high. It's going to cost 4 times our budget. The key consideration with the design is developing something that meets the client requirements, but isn't excessive and it's going to cost too much to build. And the final component of our pre-construction activities is we need to do our procurement. So procurement is acquiring the external goods and services outside the organization that we need to complete the project scope. Depending on the specific nature of your construction project and the type of company you work for, external project costs can typically cost around 70% of the project value. So really managing procurement effectively is one of the key things you can do to ensure your project comes in under budget. How do we manage procurement? Well, we need to develop a procurement plan. We need to prepare tender packages for everything we need quotes from market. For every package, we want to get between 3 to 6 quotes, 3 to 6 valid quotes. We want to choose the best for project subcontractor or supplier, not necessarily the cheapest. And then we want to award a contract or a purchase order. So we've come to the conclusion of the pre-construction phase. Where are we up to? We understand the scope. We know what we need to build. We've developed a baseline. So we've developed a scope baseline, a budget, and a schedule. We've established the systems and processes we're going to use and follow to complete the project. We've completed any design work we need to do, and we've procured, so bought everything we need to complete the project. Our materials are on site and our subcontractors are ready to start work. Okay, remember at the start, I spoke about those 3 inherent challenges to construction management? Well, let's think about those considerations now. We know our budget and schedule will be wrong. We haven't had a team that's big enough to do everything in detail, and we don't have the exact information we need to perfectly plan and prepare. Our processes and our tools won't be perfectly set up, and our procurement will have gaps. But we need to have got the big ticket things correct and ready, and our preparations should be robust. So our preparations shouldn't be so detailed that they're impossible to change later on. So now we move from the pre-construction phase into the construction phase. The construction phase is about doing the work, building the job. We're going to implement the plan. So the plan we developed, we're now going to put into practice. We're going to track and monitor performance, and then we're going to manage change. Implementing the plan really comes down to implementing the schedule. Plans have no value unless we implement them. I can't tell you the amount of times I've seen in my career somebody spend a ton of time planning and preparing for something and then not actually following the plan. So whenever we're planning, we always have to consider that we're preparing something that we can follow and then implement. Plans have no value unless we implement them. To implement the project plan, we need to understand the master project schedule. We want to turn this into a short-range program, and we want to then implement it and follow and go through this process iteratively. So reading the master schedule is where we get the context of where we're up to in the project and what comes next. We want to understand what's happened so far, where are we up to, what's coming in the next 3 to 6 weeks, what can we potentially pull forward and start earlier. Basically, we want to map our understanding of what's happening on site to where we're up to in the overall scheme of the project. Next thing is we want to take the master project schedule, decompose it, add a whole lot of detail in it, and turn it into a short-range program. So something like a 3 to 6 week look ahead. Let me give you an example of what I'm talking about. So the master project schedule might have an activity that's basement excavation. A 3-week look ahead needs to have every single task that's involved in that master activity. Basement excavation will decompose into floating the machine to site, getting the surveyor to mark it out, setting up any barricading or temporary works, excavating to 1.5 meters deep, and then setting up shoring. A 3-week look ahead is a super detailed plan of the master schedule activity. Whenever we're preparing our 3-week look ahead, we want to use the concept of pool planning. So the master schedule is just going to have a high level activity like basement excavation. When we're talking about what goes into our 3-week look ahead is we want to reverse engineer a schedule. We always want to be asking ourselves, what is everything that needs to be in place to complete the task? We want to work backwards from a specific goal or deadline, and we just need to think through what is everything that needs to be in place to complete the task. There's tools you can use to help you through this. You can try to visualize the activity. You can understand the activity in detail. One of my favorite things to do is simply to engage with the team, to engage with subject matter experts who understand in detail what's involved with the task, and then constantly be prompting them and asking them this question: what's everything we need in place to complete the next task? Now, the final part of this process is we then need to implement the schedule. So we've taken the overall activity, we've turned it into a detailed list of everything that needs to be done to complete the task. Then we simply have to do all those tasks. That 3-week look ahead becomes your to-do list. You're constantly working through the list and doing everything, constantly checking everything's ready for the next task. For example, concrete foundations. What's everything that needs to be done to complete that task on time? The pre-works need to be complete. All the materials need to be on site. We need the formwork, the reinforcement. We need to have booked in the concrete pour. We need our subcontractor who's doing the steel fixing to be ready and available. They need all their safety documentation in place, and they need all their quality documentation approved. And we need to have scheduled the proof engineer to come and do an inspection of the reinforcement before pouring. As you can see, that 3-week look ahead we created, that becomes our to-do list, and we're simply working through every single activity in the list. This process of implementing the schedule is an iterative process. Following the master schedule, developing a 3-week look ahead, putting the plan into action, it's a revolving cycle that we're constantly iterating through the project, because the reality is things are going to change every single day. We should be updating our 3-week look ahead at an absolute minimum weekly, but I would usually update it and look at it every single day. On top of this, to make things even more confusing, is there will still be some pre-construction activities going on. Works will probably start before we've done all our major procurement. You'll still need to be doing procurement. And this is where the real challenge of construction management is prioritization and focus, understanding what's important to keep the job moving, to maintain and stay on track for your schedule. As we implement the plan, we also want to monitor and control what's happening. This really comes down to 3 separate things. Monitor progress, so we want to assess progress against the baseline schedule. We want to monitor costs, so we want to compare how much we're spending versus how much we said we were going to spend in our budget. We want to monitor quality, so we want to check that things are being built correctly. Progress tracking is simply determining the percentage complete of each task and reforecasting the completion date of each activity. It's important because it keeps our baseline schedule relevant. It helps us forecast our completion date. It's a lead indicator, so it helps us identify early on if there's any delays to activities, and it helps keep our stakeholders informed and aware of progress. The key to doing this is understanding if a task is production-driven or milestone-driven. So a production-driven task is something like trenching, where it's just linear meters of trenching versus total quantity, or milestone-driven. For example, procurement would be an example of a milestone-driven task where there's set milestones along the way, and we measure progress against these milestones. Cost tracking is where we monitor how much we're spending versus our budget. The fundamental of cost control is ensuring that we're always doing the work for less than we planned, and we're ensuring profitability of the project. Again, this provides a lead indicator, so it helps us flag any variances early on when we can still do something about it. And it also helps to flag scope changes. For example, if an item of work is going significantly over budget, we can do a deep dive to work out exactly why that is. We might find a good reason where we're doing something where we weren't originally contracted to do. The specifics of how we track costs depends heavily on the type of costs we're tracking. Again, it all comes down to this fundamental question of trying to work out, are we spending more or less than our budget? For example, if we're tracking labor costs, we'd be tracking the productivity of a task, but also how much rework that needs to be done. If we're tracking procurement, we're verifying that we're getting multiple quotes, and the quotes we're obtaining are less than our budget. If we're managing plant, we're making sure that our on-hire and planned off-hire dates are less than the budgeted duration. We're minimizing the number of mobilizations. If we're tracking materials costs, we're managing things like wastage and logistics effectively. And the final part of monitoring and controlling the project is controlling quality. So we're always asking the question, are we doing the work correctly? And we're following our quality management process. Quality is critically important because it's going to help us avoid defects and rework and ensure that what we built is correct, and also provide evidence and prove to our client that what we have built is correct. Process we follow to do this will be training, making sure that the people doing the work are competent. There'll be things like inspection and testing and following inspection and test plan, then having a punch list, managing any defects and ensuring they're closed out correctly. Now, throughout this entire process, the reality is things are going to change. We know that we didn't have perfect information when we planned and prepared for the project, and things are just going to come up. We need to manage and control change throughout this entire process. We might have client-directed change where the client's requesting us to do additional work. It's going to result in a variation. We might have unforeseen events and circumstances, things that we're responsible for. So for example, if we get excess rain and in the contract, we're responsible for excess rain, and that's a risk we're responsible for. But then there might also be optimization. So things coming from the project teams where they've identified potentially better ways to do things. We have to manage all these different sources of change to maintain our baseline, and ensure we still have control over our project. So how do we deal with change? Well, how we deal with change depends on the origination of the change. Is it contract variation? Is it a better way of doing things? The next thing we want to do is we want to assess the impact of the change. We then want to approve it or deny it if requested, and then we want to implement the change. Okay, so what's the output of the construction stage? Well, we've completed the works in line with our baseline. We've checked that we've followed the plan, that we haven't spent too much money, and the works are being completed correctly, and we've verified our quality, and that we've also managed change in a controlled way. And when new works comes up, we've been requested to do variations, we've received our entitlements. And then we come to the final stage in the process, which is the closeout stage, and arguably by far the most painful part of any construction project. The closeout phase is broken down into two key steps. We've got our testing and commissioning, and then we've got our closeout and handover. Testing and commissioning is where we're proving what we've built functions as intended. So we've completed all our construction quality assurance, and we know that what we built matches the drawings. We did that during the construction phase. We've closed off our punch list, and then commissioning is where we test to see what we've built functions as correctly. So if there's errors in the design or the project requirements, these will come up through the commissioning stage. So this is different to construction quality assurance, where we're verifying that what we've built matches the drawings and specifications. Commissioning is where we test and prove that the systems we've built match and fulfill the original project requirements. Then the final step is when we've finished the project, we've proved everything functions as required. We have to then now hand it back over to the owner. We have to pack up our side sheds, demobilize from site, and give the owner, the project developer, a finished project. So we'll conduct things like handover walks, joint defect inspections. We'll agree and close out the punch list. They'll accept all our quality assurance documentations, any witness testing and commissioning. We might need to hand over any spare parts. We might have to conduct training for them to show them how different systems operate. And we'll need to give them an operations and maintenance manual. Again, these specific requirements will depend on the contract, but these are typical activities that take place to hand over the finished project. So as an output of the closeout phase, the client has accepted the finished work. They've given it their tick of approval and said that we've delivered the project successfully. They'll close out the contract and they'll return any security or retention they were holding. Okay, so I know we covered a lot, but let's just briefly summarize the process we went through to deliver a construction project. We went through the entire process is set to transform a set of requirements and specifications into a finished product. We spoke about the three key challenges, which are insufficient resources, progressive elaboration, and the loss of control as the project progresses. And we spoke about for us, this means to successfully deliver a project, we need to be able to prioritize. We need to be adaptable, and as the project progresses, we lose control. So where possible, we need to make an upfront investment planning. And then we went through the steps to successfully deliver a project. We spoke about the steps during the pre-construction phase where we set the project up for success, the construction phase where we implement the plan, and then the closeout phase where we hand over the finished product back to the project owner.